Hello and welcome. I'm Aravinda, your instructor for the course on bare metal embedded programming with Atmega 328 microcontroller. In today's lesson, we shall learn about the fuse and lock bytes. The lesson is accompanied by a hands-on session in which we shall program the fuse and lock bytes. This will configure the Atmega 328 for the further usage. There are 4 bytes in a separate non-volatile memory area, which is used to secure the code in the microcontroller and configure it. One of those bytes is lock byte, while other 3 are fuse bytes. Lock byte is used to restrict the access to the flash and EEPROM and provides security against the unauthorized access to the on-chip memory. The access restriction can be applied at 3 levels: no restriction, disable programming, that is write operation in parallel and serial programming modes, and disable programming and verification, basically the read and write operation in both the programming modes. Lock byte is also used to restrict the access of the 2 sections of the flash memory. Those are application section and bootloader section. For our purpose, the desired value of the lock byte is 3F. Fuse bytes are used to configure the microcontroller. There are 3 fuse bytes named extended fuse byte, fuse high byte, and fuse low byte, and are identified using eFuse, HFuse, and LFuse respectively while programming. The 5 most significant bits of the eFuse are unused, and the rest 3 bits are used to configure the trigger level of browned out detector. We shall program the fuse byte with the value FD. The fuse high byte is used to enable or disable external reset, debug wire, serial program and data downloading, and EEPROM data preservation through chip erase. It is also used to configure the size of bootloader section and select the reset vector. The LFuse is programmed with the value DE. The fuse low byte is used to enable or disable divide clock by 8 and clock output. It is also used to select the startup time and clock source. We shall program the fuse byte with the value FF. It is important that fuse and lock bytes are programmed with the values mentioned. For example, the default value of the clock select in fuse low byte selects the internal RC oscillator at 8 MHz. But we are using 16 MHz external crystal oscillator, so the clock select must be initialized to the binary value 111. We have already wired the base circuit with in-circuit programmer and learned about the AVR-DUDE program. Let's check the value of the fuse and lock bytes and program those as necessary. Connect the development board to the development PC through the in-circuit programmer and use the AVR-DUDE command as shown. Use the interactive mode to read the value of individual bytes of fuse and lock bytes, and use command line mode to program the fuse and lock bytes. Launch the command line interface and use AVR-DUDE program in interactive mode to read the fuse and lock bytes. Use the command AVR-DUDE -P M328P. The -P option tells the AVR-DUDE the microcontroller being programmed, and the value M328P identifies the Atmega 328P microcontroller. The -C option specifies the programmer being used. For us, it is USB ASP. The -P option specifies the port on the development PC to which the development board is attached to, and for us it is USB. And -B option is used to override the default baud rate. I will use the value 11 5200. And finally, the -T option to put the AVR dude in interactive mode. You can see the AVR dude prompt indicating the interactive mode. Use the help command to list the commands supported. It supports various commands like dump, read, write, erase, etc. Let's read the fuse and lock bytes using read command. Type read lock to read the value of lock byte. The value is 3F, which is the required one. Type read efuse to read the extended fuse byte. The value is FF for me, so the extended fuse byte must be programmed with the value FD. Use command read hfuse for reading the fuse high byte. The value is DE, which is the required one, so no need to program it. Now read the fuse low byte with command read lfuse. The value is DF. This needs to be programmed with the value FF. Now let's exit the interactive mode with quit command and use the command line mode of AVR dude to program the extended fuse and fuse low byte. Type the command AVR dude -M328P -C USB ASP -P USB -B 115200. Now use -U option to specify the memory operation to be performed. So first we'll program the extended fuse byte with efuse :W. W stands for the write operation and the immediate value of FD and :M. M specifies the immediate value supplied. Again use the -U option to specify the fuse low byte. -Lfuse :W 0xFF :M. The fuse bytes are programmed with the new values. You can use the interactive mode again to ensure the changes are correct. With this, we come to the end of this lesson. I hope you must have enjoyed the lesson and learned something new.